Good morning, guys. So today I'm going to try this recording thing with you. I'm going to start by looking at the coding of the nervous message by the receptor and the nerve fiber. Now, obviously, we worked on this before with the PowerPoint presentation and the worksheet. This animation, despite being in French, can help us to solidify the knowledge and to make sure that you got the idea. So first of all, this is the apparatus, the setup we have. This is obviously the receptor, the Pacini corpuscle, which, as you should know by now, is a receptor sensitive to pressure. It looks something like this. You can see it's circular, sort of oval shaped, with several layers of lamella forming a structure very similar to an onion. It's located within the skin in the dermis. Its job is to absorb pressure, this stimulus, this mechanical stimulus, and to be activated and thus to form action potentials which will be transmitted by its fibers to the CNS. So let's return to the setup here. Again, this is the Pacini corpuscle. This is the receptor part of it. This is the nerve fiber which is going to transmit the messages away towards the CNS. And this is the stimulation device, which is going to apply pressure as we hit on the Pacini corpuscle. It will deform, and then it will start to form action potentials. So let's give it a try. Again, we're going to record the messages along the fiber here with the microelectrode connected to the oscilloscope. The first pressure we're going to apply is going to be very simple, very small pressure. So notice it gives barely any deformation in the corpuscle, but you notice that it helped to generate these two waves, which we call action potentials. That's true. Well done. Now you notice that the amplitude of these action potentials that's true, it's constant. Yes, it's the same. This is because this is inner fiber, meaning it obeys, well done, the law of all or none. How about if we increase the pressure even further? So let's take a medium pressure here. Moya means medium. You notice that the deformation is stronger now, and what do we see here? Did the action potential amplitude change? Of course not, because again this is a nerve fiber. But what did change is the number of the waves recorded. So now we see double the amount, double the frequency. 2 action potentials at first, now they are 4 action potentials. Okay, so let's increase it even further. Let's go for a stronger pressure. Applying a very strong pressure here, you notice a very strong deformation of the capsule. And then what happened to the frequency? It increased even further. Now we have 1, 2, 3, 4, 5, 6 action potentials, all of the same amplitude. So what does this show? I'll give you a second to think about it, and then we'll write our own conclusion.